Hey there, Mr. Kolu here with a little more Kolu math. Today's lesson is brought to you by trainingvids.com. It's a great place to get a customized training video or an interactive assessment. Alright, so before we get started here, please do make sure you check out our video on perimeter. That way you can kind of catch up with the story and I won't have to repeat myself. And you'll be kind of out of place here. So, yeah, let's get started. So today we are going to be talking about area. And a definition for area would be the number of squares that occupy a flat space. Okay? Let's try to friendly that up a little bit here. Maybe occupy we could think of as fit, and maybe flat space we could think of as a shape. Okay? So the number of squares that fit inside a flat shape. That's not too bad. Because last time we were talking about the outside of a shape, right? So if your job was to trim the edges of this lawn,
the only feature that would really concern you would be the outside length, or the perimeter.
Now if it's your job to mow the inside of that grass, you're worried about something completely different than the perimeter, right? Doesn't matter how long it is around. You're concerned with how big is it inside. And that's what we call the area. Okay? Perimeter, distance around, area, how many squares fill in that area. Okay? And we just use squares because they're easy to count. So let's go back to our story with the farmers. And last time we saw these guys, they had just ordered their fencing. They got that all installed. And by the end of the day here, everybody had their fence all set up for the next day's planting. Okay, so the next morning, the old farmer wakes up, and he wants to determine how many bags of seed he needs to plant for his whole field. He wants to cover that whole field, the area inside, right? Well, how's he going to do that? Well, the old man's pretty resourceful. He takes a look at the bag of seed, and he sees corn seed, 1 seed per square foot. So that square foot kind of tips him off a little bit. So he gets out some blue paper, measures off 1 foot, and cuts out square feet. Squares that are 1 foot long on each side. And then he takes these square feet and he lays them out in his field. Yeah, that probably takes a long time. Let's hope it's not windy. Okay, so once he gets them all laid out, he goes around and counts them up and puts them onto his notepad. When he's finally done counting, he finds out that he has 336 square feet. All right, but again, the young farmer, he tries to be a bit more creative with how he solved these problems. So he's still wondering how much seed does he need to fill the inside there. And he looks at his seed bag, and his carrot seed bag says it covers 20 square feet. Okay. While looking at his notebook, he realizes, wait a minute, he's already got squares in there because he drew on graph paper. Isn't that awesome? So he starts counting up the squares. But by the time he reaches the second row, he realizes something. Well, wait a minute. I'm always counting 13 because there's 13 columns. And I'm going to do that 9 times because there's 9 rows. So I bet I could just multiply those two together. And sure enough, you can. That'll help you count all the squares without having to count each individual one. So 9 times 13, you get 117 feet squared. And then they both run down to the hardware store to put in their orders for seed so they can get started planting. Okay, so what we saw there were 2 different methods for determining area. We saw kind of an almost comical but very literal understanding of how to calculate area. And then we saw a shortcut used by the younger farmer. And I think we both know which one was preferable, don't we? Yeah, area is best solved if you can find a shortcut. So we've got this figure, okay? We'll call that a rectangle. And the way you calculate the area of the rectangle is the same way the young farmer did. He multiplied the height by the base. Let me put in those values so you can see there, right? Just what we did, the number of columns by the number of rows. Okay? So that's our formula for area of a rectangle. Now check this out. If I take out my pizza cutter here, and I cut this shape in half, what am I left with? Yeah, it's got the 3 sides. We're talking about a triangle. Okay, what did I do? I cut it in half. What do you think I have to do to the area? Yeah, I have to cut the area in half. And in fact, that's where you get the formula for the area of a triangle. 1/2 height times base. Okay? Let's take a look at another one. So back to the rectangle here, okay? Height times base. What if I take my pizza cutter and cut off a corner? Okay, I remove that corner, and I move that corner to the other side. Okay? What shape have I got now? Do you guys recognize it? Maybe these will help. Remember, those little marks tell you that something is parallel. When you've got 2 sets of parallel sides, you've got yeah, that's right, a parallelogram. But do we have to change the formula? Well, if you remember, all we did was move one corner to the other side. So no, we didn't change the area. We have the exact same equation for calculating the area. Okay? And remember, that's because area is just a group of squares, okay? The amount of squares it takes to fit a place. And you can move it around. Think about it like a rug. You know, if you cut it into pieces and kind of replace those pieces of a rug, you'd still have a carpet. It might be a different shape, but it would have the same area. Because area is just the number of squares that fit inside a flat space. Okay? Let's take a look at an example. All right, what is the area of the figure below? And here's the figure. Let's let it draw out. Okay. Well, we've got to figure out what kind of figure this is first, right? You might be able to guess right off the bat, but let's kind of pretend like we don't know what's going on here. We've got these markings here, those right angle markings. Okay? That's actually telling us quite a bit. Well, let's take out our handy-dandy geometry textbook here, crack it open, and see if we can match it up. Okay, we got a parallelogram over there. Do those drawings look the same? Nah, it doesn't look like it. Trapezoid? No, I don't see those 4 right angles. Let's keep going here. Oh, perfect. Rectangle, right? Take a look. We've got 4 right angles. We can match that up because all rectangles have 4 right angles. All right, and we can actually match up the markings we have, the measurements on the left-hand side, with the drawing on the right-hand side. So 6 is our B, and 4 is our H. All right? Now it's really simple. All we have to do is plug that into the equation. So here's the equation. Area equals base times height. Let's plug in base and height. Go ahead and do that. We get 6 times 4. Multiply that out, and we get the area is 24 feet squared. Okay? You guys realize why you have feet squared there, because we're literally talking about square feet. Okay? There's 24 square feet in there. Okay? Let's take a look at another example. What is the area of the figure below? Let's let that figure draw out. Okay. Interesting. There are the measurements. So same deal here. We've got to match it up to the same drawing in the textbook. There's a trapezoid. We've got parallel bases, just like it says. And we have all the information we need to solve this. We know that 10 is B1, 7 is B2, and 5 is H. So let's go ahead and plug that in. There's the equation. Plug in the important numbers where they're supposed to go. That gives us A equals 1/2 times 5 times the quantity 10 plus 7.
Following the rules of PEMDAS, let's complete the parentheses first.
So let's do 10 plus 7 is 17.
Let's multiply 5 and 17 together.
That gives us 85 feet squared. We still have a half out front to deal with. Let's multiply 85 by a half. That gives us an area of 42.5 feet squared. Okay, just that simple. Let's review the procedure. First, you want to determine the shape. Use the symbols, the measurements, the words in the question to figure out what kind of shape you're talking about. Rhombus, parallelogram, trapezoid, okay, that kind of thing. Then you're going to go ahead and consult the formulas. You can use the textbook, the internet, or your memory. Just make sure your memory is correct. All right, and finally, you're going to plug in and solve. You're going to match up your drawing with the formula, plug in the question's details, and solve the equation. All right, just following this is probably going to answer about 80% of your questions on area, the simple ones. Obviously, things can get more complicated, and we'll talk about that going forward. But that wasn't too bad today, was it? Okay, yeah, stretch a question, sure. I guess we're due. All right, let's take a look at it. If the area of the figure is below 60... wait a minute. Look at this question. I mean, this is like way different than find the area of the figure. I mean, the question is really the most important part. You know, you have to make sure you take a good look at it and understand what's going on. So let's really read this thing here. If the area of the figure below is 64 inches, what is the length of side Y? So what this does is this sets off alarm bells in my head that this is not about calculating area. You already got the area. We want to go back, okay? Oh, and in case you didn't know, when you see a dashed line in a geometric figure, those lines are not actually part of the figure. They just provide additional information. Like in this case, the height of the figure. Let's go ahead and do step 1 and figure out what kind of figure we have. Do you guys know? Got 2 sets of parallel sides. Right, talking about a parallelogram. Great. You may notice that this looks a little different than the drawing because the height's on the inside rather than the outside. But that's the cool thing about height is it can be on the inside and it can be on the outside. It doesn't matter. It's just showing you how tall it is. Okay, so let's go ahead and do it. We've got our formula, area equals base times height. Let's plug in what we know. We've got a height of 4. We can plug that in. We've got a b of y. And, well, that kind of sets us with a problem, doesn't it? Because now we have two variables and can't solve an equation with two variables with just one equation. Oh, but take a look. We actually know some of this. We actually know what A is, right? Because they told us the area. The area is 64. Okay, let's go ahead and plug that in.
Okay, so that leaves us with 64 inches squared equals y times 4 inches.
Let's go ahead and divide both sides by 4 inches. Okay, that gives us y equals 16 inches. Just that simple, okay? All right, well, that was pretty great today. Next time, we'll take a look at harder questions involving area and perimeter and work on some strategies for how to solve them. Okay? See you next time, guys.